Well, students, soil horizon designations. Designations is nothing but we are giving some symbols, some identification characters like this. So for example, as we discussed, accumulation of clay, we will give one type of designation. So mostly we will say BT, we will give that type of names. Or accumulation of organic matter means we will give O. Like that, we will give some names to that particular layer, particular horizons. So we'll give different names to identify the morphological characteristics. But remember, students, these names are guide only. It will give some normal horizon name. It will give some guide, but it won't give any idea regarding the diagnostic horizon names. So diagnostic horizon names are quite different, which we have discussed in the previous lectures in soil taxonomy, which is quite different. So horizon normal, no, mostly students, the designations, these horizon designations was changing from year to year. Now, if you will see many nominations were completely changing from after getting some new characteristics, they will change. They will change, or they may modify that name, or sometimes they completely replace it. Best example, handbook of key to soil taxonomy USDA. Mostly in Indian conditions, we most of the pedologists are using that reference only, key to soil taxonomy. Anyone can download that one in from USDA website. Anyhow, this is recently, yes, students, in historically this nomenclature was completely gone to several changes. It was completely several changes. So I'm taking 2010 notations of 10 notation means there is no much change. We can even if you see very recent 2019 or 20 edition, if you see also, there will be no that much changes, very norm changes. Anyhow, we will discuss all this nomenclature, how it will be gone. So very first, students, has we know that master horizons and layers. So master horizon, these are the main horizons, students. So these master horizons will completely represent in a capital letters. So in particular profile, if you see master horizons means definitely master and main horizons. So if you see main horizons, we will designate it as capital letter. In that, students, oh, everybody knows in soil profile, in soil profile lecture, I have mentioned very clearly what is a O. O is nothing but it is a horizon layer dominated mostly by organic soil materials. Inside that O, there are many layers. We will see. We have explained this about in previous lecture. Even now, we will see about in detail regarding coming slides also. This is one. O means if all of a sudden if you report any O in a particular report, if you mention O means that particular soil horizon is comes under the organic soil material. That's so that particular layer was completely dominated by organic matter. If you give a nomination called, or if you give a notation called O. Coming to the L, students, L is nothing but horizon layers or organic material, mineral, completely limnatic material. Limnatic materials are nothing but there are some aquatic minerals. So what are the depositions are taken place by the aquatic organisms? We derived from the aquatic plants or aquatic animals, etc. Those aquatic depositions are called the limnic material. So don't confuse. Limnic material means are the deposited in the water by aquatic organisms. So remember this term, students. Limnic material. These are nothing but deposited in water by aquatic organisms. So derived complete from where this deposition is complete derived from aquatic plants, subsequently from modified aquatic animals also, from both animals and plants. So limnic materials include, so this so-called aquatic depositions, which includes, what are those includes? We can see corpogenous earth, we can see corpogenous earth and diatonomous earth, and marl L horizon. Mostly this L horizon were completely used in only in histosols. Remember, students, in histosols only you can see this denomination or this notation. You can see only in histosol, this L notations. So what is the meaning of corpogenous earth cell? Corpogenous earth are nothing but there are the sediments, mostly organic sediments of peat. Peat means nothing but some partially decomposed materials and some fecal pellets, some pellets of this animals, aquatic animals, etc. So diatonomous earth means, students, is nothing but it's a soft, silicaceous, sedimentary rock material, which is a very which even mostly, especially in horticulture crops, especially when they're going for insert cultivation, or if they want to grow anything in particular cups or somewhere in very for lab purpose, this material they almost most of horticulture or any greenhouse persons, this is very costly. They use this diatonomous earth also sometimes for mixing the combinations they may use. So this is regarding the diatomos. So this limnatic materials includes the depositions of mostly aquatic animals and plants and animals. Mostly, students, remember this L horizon is mostly used, mostly means almost used only in histosols. Only histosols only you can see this L horizon. So remember this point. Okay, students. Coming to the next is A horizon. A horizon, everyone knows it's a humified organic matter mixed with mineral mixture. So you can see here, you can see some organic material you can see, and also mineral material. So completely what will happen? This mineral, where these combinations are formed? Completely from decomposition of plants and plant residues. And sometimes you can see some properties have resulted from cultivation, pasture cultivation, some physical disturbance by us, by our agriculture practices. So mostly you can see some fine stratification of sediments or some evidence of elevation. You can see sometimes you can see evidence of elevation. You know all these things which we have discussed in the profile itself. So mostly in A horizon you can see elevation characters of clay salts and all these materials, aluminum compounds and soluble organic compounds. Everything will be completely, what will happen? It will leached out. Yes, it will be leached out. So from here, everything will be leached out and deposited in the subsequent layer. What are the layers? We will see that. So E is E horizon. So A, after E, we will see another major horizon is E. E is nothing but the loss of organic matter. So almost everything will be lost. Mostly, what is this E horizon is called as? Anyone have any idea? What is the meaning of E horizon?
Alluvial horizon.
Yes, alluvial horizon. Yes, yes, very good. Alluvial horizon washed out, complete. Nothing will be there. Everything will be washed out or leached out. Everything will be leached out. All the materials will be leached out, and you can see have a lighter colors than overlay. Due to that leaching, students, what will happen? Only some resistant material will be left out in the E horizon. But students, the overall students in E horizon have very lighter colors. And compared to the A horizon, A and underlying B horizon, this E horizon has very lighter colors because everything was leached out. So mostly this color A and B most, why? Because they may directly underline O horizon. So E horizon may E horizons are not present in many soil students. So mostly E horizon will be present, but it won't occur in most of the profiles. So E horizon will occur at very rare cases. So B horizon also is a mineral horizon, students, followed by OA and or E. So E may be, E is an optional, may be present or may not be present. So sometimes O also will be there, A also will be there. So in after O and A, generally B will be present. So parent material is significantly altered, students. Why? How it is altered? Because whatever the leached material from A is there, completely there will be accumulation of silicate, all the silicate, clay, aluminum, everything will be deposited. And sometimes we can say removal of carbonates or gypsum. So calcium components like carbonates or gypsum, definitely we gonna lose all this. That's why you can see some alteration of parent material will be taken place in B horizon. Coming to next, so this alteration, what will happen, student? Due to this alteration form, brittleness we can see, development of soil structure you can see, and we can sometimes we can say redness of the soil, like color, glaying also, especially glaying, student, especially in submerged conditions, this glaying we can see, and residual concentration of oxide compounds we can see. So like this, we can see many things. So there are many kind of B horizons, many kinds. We can see different kinds will be the based on the conditions prevail in that particular area. So we can see some due to different phylogenetic processes, we can see some depositions will be there, some leaching will be there, so even some gelling characters also will be prevalent in the B horizon. So based on the conditions, so we can see many kind of B horizons. What kind of the B horizons we will see in coming slides. So C horizon, student, another master horizon, C horizon. This is also a strongly cemented and hard bedrock, students, with a very little or no alteration by soil forming process. So very little horizonation. So very little or no alteration by soil forming process. So C horizons are layers lack of, what will happen? It won't have properties of the horizons which we discussed above. So you can't expect anything, students. So here, because almost the soil development was very little, students, very little, you can see there is strongly material, adhered materials are very less, but you can see only some root materials, that very taproot materials. And when those root materials were died or when decomposed, some organic carbon will be added to this particular C horizon. So only that thing will be happening in C horizon. So C horizon is almost filled, but it won't have any characteristics of OA, E or B. So this is regarding C horizon. C horizon only organic source we can see only from big taproot systems of trees, etc. So next is R horizon, students. R horizon. These are strongly symmetric and durable. So rock material, complete R means completely you can see rock material that's a very hard and hand digged with a spade. With a spade is impractical, even when the material is moisture in this. So even this rock, this is a very rock material. R means very or completely recover it, all those things will be there. So it is very difficult. Even we can't remove with the spade. It will be very hard. Even if we give some moisture also, it is very difficult. We can't remove that bedrock from that particular profile. So small cracks, practically are totally filled with soil material occupied by the roots. If you see any small cracks, naturally sometimes if you see any cracks in our horizon, generally what you can see is that will be occupied by some soil materials or sometimes by root materials. But frequently our layer is even most of time we can't see in all orders even, but when we completely go with very deeper depths only we can see this R horizon. So regarding with M students, M is completely man-made students. Everything is completely man-made conditions only. All the human, and also it is a very root restricted area. There is no possible. But here, at least if there is a cracks, there is a chance of occupying roots. But here, there is no place for any root development or anything. So it's completely human manufactured materials you can see. What are the conditions? You can see concrete, you can see geotextile, liners examples. Sometimes you can see all those type of materials. This is a man-made horizon. Coming to W student, W are nothing but water table. So whenever I dig a profile, if you see any water conditions, so that particular horizon is called as, you can give a designation called W or notation called W. So that water may be sometimes that water may be any of time. That may be organic soil material in floating bog, or you can say permanently frozen. Sometimes if you are in a very humid conditions or very temperate zones, you can see permanently frozen conditions also. And remember, student, this so-called water is cannot be compared with our shallow water, snow or ice. That is quite different. This water composition is quite different from this. So whenever you see any water source in a particular profile, you can give the name called W. If there is a W, based on this, we can see how much depth the water table condition is there in that particular area. So transition, student, this is what I'm saying. So transitional and combination of horizons. So this is what very important, transition and combination of horizons. So transition means, so whenever we travel, say for example, yeah, this one. So whenever we see a profile, this is a profile mostly. If it is a very forest area, or you can see some horizon, you can see some bits, some organic material, all those things, and later you can see A and B, C, R, and if case has I said W or something will be there. That is the difference. So generally what we will see O we can see, A we can see, or if possible we can see the E also, illuvial horizon. E also we can see there. And B we can see, and down we can see C. So like this students, we can see O, A, E, B and C. So transformation students, whenever you can see, there will be some small particles here. So thin layer will be there. The transition layer will be there in profile. So what will happen means, in this layer, you can see some dominating features of A and some minor features of B also. If it is not a E horizon, or sometimes you can see horizon. So we will designate this type of layers like this. If you have dominating characteristics, you will put as A, and and also you can see some minor properties of B profile also. Then you should say that transition layer is nothing but AB. So you should mention that AB, the transition layer. So the transition, the change was happening period, it is called the transitional. Or sometimes you can see combination of both also. You see, sometimes you can see A and B also, you can see the combinations. So those are called the combination horizons. So those are also called the combination horizons. So what will happen means, students, when a horizon is substantial thickness is present between the two master horizons. See, between, that is what I'm saying, two master, just now I explained. Well, what is that? A and B. So between two master horizon, a transitional, generally transition means changing, or combination horizons may be present. There are changes sometimes, that A, when we are moving from A to B, in between that A and B, there will be a thin layer, or sometimes there will be a substantial thickness. Sometimes based on the climatic conditions, that layer will be very thick. So based on the thickness also, we have one classification which I have discussed in the last video. So last lecture. So that transition, that is called the transitional layer. So this transition layer is completely student sometimes may be dominated with one property. Say just example, if we give the transition name called AB, if we give a name called AB means what will happen? That particular transition layer is dominated with A features and have some minor features of B also. That is the meaning of transition layers. Both if you have though if both are dominated by two master horizon means we should give the two master horizon letters. And mostly student, the first letter indicates, this is what I'm saying, indicates dominating of master horizon. Second letter indicates the subcoordinate horizon character. Subcoordinate is some minor characteristics. That is what I mean. So the transition, the changing. Just for example, if I want to speak very informal way, whenever you're crossing from one state to another state in India, especially when you're traveling from say for example when you're traveling from, how can I say, yeah, when you're traveling from Andhra Pradesh to Odisha, in between Andhra Pradesh and Odisha there will be some areas will be there. What will happen in that area? You can see some mixed cultures. That mixed culture you can see there, those people have some Andhra culture and those people have Odia culture also. So that you can say transition, you can say some transition will, that is a transition culture or combination cultures will be. Same thing here also is happening in our soil profile also. We can compare like that. So whenever you're seeing A horizon, B horizon, then you can see dominating characteristics. So if it is dominated by the A particles, A characters, you can see A by B. So like that you can do. That is called the transitional or combinational horizons. Okay, students. So this is regarding. Now we will see in detail about this. What are the, how many types of transitionals are there? How many type of combinations are there? So what are these? We will see that. So this is what students, transitional combination. Let's see, if this is a, but here you can see some different type of layers. What is this, sir? What is this U1, U2, U3? We will see this one. What is this BTF, BTFC? All these things we will see in this coming lectures. But just for your understanding, we see this. It is A, it is B, but you can see in between while we're traveling from A to B, there we have to cross these two layers. So AB means in this particular layer, A characteristics are most dominated, B are minor. So slowly if you move down, here B characters are dominated, A have minor characteristics. But if you go on slowly down, you can see in different. What is the small letter BT1? So we will see there is a particular meaning for the small letter T1, T2, T3. We will discuss in the coming lectures also, even this one also, BTTFC, we will see all these things. So this is the best example. This is for understanding the about what is the transitional combinational layers. Okay, students, now we will see in detail regarding that. Yes. Yeah, this is right. Best example. This is what students I'm saying. What is the A, B means is transitional, A has, so these are dominated, which I have explained. So BA means generally B is dominated, A has minor characteristics. If we will give notations like this, BA, AB, like that, student, transitional functions. And also you can see some combinations, different combinations, maybe AE, EA, EB, BC, BD, like this. We can see different combinations in particular soil profile. So this is what I explained in my, I give an explanation regarding this also. Coming to the next, students, combinations. So just I said, so the same thing, students, I've already explained. This is for your reading purpose, students. So combinations, we can see different combinations. Based on combinations also we can give different symbols. So subordinate designations within the master horizons and layers. Subordinate distinctions. Say for example, students, generally most of the oxides, so whatever the material was leached out from the A profile, or sorry, A horizon, that particular material will be deposited in the B. So the deposition will be various, students. The depositions may be silt, the depositions may be clay, maybe iron oxides, aluminum oxides, or sometimes SQ oxides also. We can see different depositions. So based on depositions, that accumulation also we will give different small letters. So small letters designation we will give. So mostly students, this so-called subordinate designations, that small letter designation, nothing but called subordinate designations. We call it subordinate designations within the master horizons or layers. So generally, how we will give the names for that particular subordinate designations? By only the accumulation material. Depend upon the accumulation material, we will give the particular name or particular designations. Now we will see one by one what are those things. A, first of all, if you want to give A means, so for example, A example BA, master horizon B, this is this subordinate horizon, just you can say this one. Subordinate designations. So like that. Okay, so it is mostly what will, where you can see, students, OA. I hope whenever if you see my previous lectures, OA means highly decomposed materials. If you're mentioning this A in any master horizon, you can see highly decomposed material. Mostly that material should be around 70% volume. By volume, it should be around 17%. It should be there. That is called the A. A is A. If you give any A, small a means it is completely highly decomposed organic material. This is subordinate. This is subordinate designation. A, this is small a means subordinate designation. Remember that. And B means which is not a buried genetic origins. Buried genetic origin means some buried materials like some genetic materials will sometimes buried. Mostly these are not used in organic O horizon, but here you can. But this A will be used in organic. C means concretion. So if you use small c, subordinate notations, subordinate. What do you say? Subordinate designations. Subordinate designation, what is that? That indicates the accumulation of iron and aluminium, magnesium, titanium, cementation of concretion or nodules. C means, okay. The hardness or consistency of concretions or nodules should be described. So C means concretion or nodules. The concretion nodules nothing but accumulation or it shows some significance of iron, aluminium, magnesium, titanium, etc. So like that, we will give all those meanings. So CO means corpogenous. So I have said what is the meaning of corpogenous. CO. If you give any small CO means corpogenous F. That is nothing but a limnatic layer corpogenous F. Generally, if I want to say if I want to give a name called like this, if I give my name like this, what is that? See, if I give name like this, O CO like this. We should write like this, students, in profile description. That means all of a sudden, if I read like this means what? Oh, okay, there is a O horizon. That O horizon was completely dominated with some corpogenous limnatic material called CO. Corpogenous material is there. So then I will get an idea. Like this. We should give some notation. This is a method of notation, students, mostly used in taxonomic classifications. So So D, next come with the D. Small d means physical root restriction. In this type of subordinate notations, we can see only some physical root system. So this symbol mostly used for non-cemented roots restricted area only. So natural occurring human-made layer. Generally, we can say our hard layers, like whenever we hard pan by using our heavy in the tillage activity, there will be formation of large, big plow, hard pans will be there. So the entry of root was completely compacted zone. So root does not enter except along the fractured planes. Only in some fractured planes only we can see this. So that if you have found that type of any physical root restriction plane or hard pan, you can see means you can give the name called D. Di means diatonomous cell. See student, that is the difference. So CO means corpogenous cell. Di means limnatic layer of dimetric. So there is a two different types of in L itself. There are two materials are there. Which material is dominant? If for example, if I want to write like this, so there is a O horizon. There is a L horizon. Even you can say O horizon. You can give that name also. If O is dominated with some L properties means so organic layer. You can see a limnatic material. What type of limnatic material is there? If there is a diatonomous, then I put small di. So this you should write like this in while giving any description to the particular profile. So these are the two master horizons. So there is an organic layer. In that organic layer, there is a limnatic property is there. In that limnatic property, which type of material is dominated? Diatonomous material. So Di. So why this need of all these short notations? It is very needed because we can't write all this in pages and pages. We can't write all this material. So I have digged a profile. In that profile, I have seen some organic layer. In that organic layer, there is some limnatic material. In that limnatic material, there is a corpogen. So it is very difficult. That's why we simply give these notations. So that is the meaning for this. That is a simple meaning for this notations. Now we will see another one. So remember this students, especially SRF students, you remember there is a chance I'm expecting some questions because it's newly added syllabus. So diatonomous material. Coming to the next students, E. So E, organic intermediate decomposition. Generally students in soil profile description in my previous lecture, I always mentioned OE means it is an intermediate decomposition. So there is no complete decomposition. So mostly you can see rubbed fiber around you can say around 17 to 40% you can see knee horizon. Whereas F means it is a frozen soil or water completely. If you see any notation, F means it is completely that particular layer as a frozen. Say for example, students, especially we have seen. So there is a B in profile. There is a called B horizon is there, master horizon. In that master horizon, I have found some frozen ice, especially mostly you can see in Antarctica or some polar caps like Russia. Even in India, if you want to see, you can see Himachal Pradesh or Himalayas, you can see. So I have found a B master horizon. In that B horizon, I've seen some water means or some this thing I have seen frozen layer I can see means. Then I should mention like this BF, B small f. So I should put like this. So all of a sudden, if I see in the paper I've seen this means okay, that particular area there's a B horizon is there, but was completely dominated by frozen soil or frozen water is there. So like that, I will get some idea. I will get means that particular person, the particular scientist will get some idea. So like this students, FF, if you put double F means dry permafrost, indicate the horizon continuously cooler than the zero, so zero degree. That means we can't see there is the only difference is that students, you can here you can see you can't see any not cemented by ice. Here you can see here also you can see dry permafrost, some frosting material you can see. Here you can see ice, but you're in some frosting material. Some frost means that snow type of ice you can see here. You can see, but it was not cemented by ice. So see, the particular soil was not completely cemented by ice, but here you can see complete frozen. You can see soil and water completely frozen here. That is it. That's the difference between small one F means frozen, double F double F means there is no any cementation in the soil, but here you can see some cementation. There is a difference. These are the difference between small one F, one small F, two double F. So if I go for G, this is strong glaying. So strong glaying, especially you can use it this in B because we have discussed about the B. So you can see some glaying we can see origins either it has a because of well we can see some ashy material. How we can see because of reduction students because of reducing of red oxides or sometimes by removal of iron oxide saturation conditions. All these conditions we can see some ashy material, some ash color materials. Mostly stones also you can see. So if you see that type of material, or that is called glaying students. So generally that is called a strong glaying. And last time we have conducted an exam, we have asked this question, but yeah, everybody given right answer, but the form was not giving right answer. Everyone have glaying material, but it giving some other answer. But remember, students, that is a glaying. Strong glaying is the right answer. Anyhow, students, coming to the next. So this glaying material, complete students, you can see some different color domination. Mostly gray, it will be due to this submerged condition. You can see gray color. So that gray will have different hues. You will get this type of hue students, the Munson color stuff. So like that, you can see different redox conditions we can see. And this G material is low in chroma, not using material with low in chroma. If G material is very low in chroma, we cannot use this. So there is no evidence of saturation of viscera wetness in E horizon. So E horizon or in C horizon developed from the parent material with low chroma. So this is the reason. Remember this point, student. They may, if they want to ask very strict questions, they may catch this type of lines. So G is not used in the material with low chroma that have no evidence of saturation or history of wetness, as in many E horizons or in C horizons developed from the parent material with a low chrome. So this is the student. So G horizon, whenever there is a low chrome conditions where there is a no saturation of wetness, mostly you can see in E horizons or C horizons developed from the parent material, you can see low chroma. So when there is a low condition of chroma, that condition, this G notation cannot be used, so they won't use. So remember this line, students. So everyone can understand this, but remember this one line. It is very important. Coming to the next, students, H. It is the accumulation of alluvial accumulation of organic matter, students. Usually not only in B. Sometimes the H is indicates the alluvial accumulation of amorphous dispersed organic matter and sesquio oxides. So if whenever I say H, it is a alluvial accumulation of organic matter and sesquio oxides. Mostly alluvial accumulation of not only this organic matter, these materials also included. So mostly the sesquio oxide dominated by aluminium, but that is very small quantities. This is regarding the H. So if you want to notate anything means BH, so you should write B and H. You should put like that. So if I go for I means it is very slightly decomposed. See students, I think you should not be confused. Previously we have discussed light decompose, intermediate decompose, but here I means completely decomposed. So if I mention OI means any particular horizon means you can say that completely decomposed material. So mostly we can say about 40% as you can say fiber content, we can say organic fiber content, mostly we can say only 40%. This is regarding the I mean I students. This is H and this is high. This is explanation for H, this is explanation for I. Coming to the next students, J. J is nothing or mostly this type of J you can see in acid sulfate soils. Wherever there is a problem called acid sulfate soil, you can see You can see the accumulation of Jurassite. What is the Jura? It will be Jurassites are looks like this, students. This is the image for Jurassites. Mostly where there is a dominated by the sulfur, you can see the oxidation. So generally, whenever this type of particular material, when the sulfur material was buried under the soil, means there is no problem. Whenever that particular sulfur material was exposed, what will happen? All of a sudden, it will be react. The sulfuric material will completely reversely. What will happen? It will convert into sulfuric, so that definitely will create acid sulfate cells. So during these conditions, what will happen? The soil will show some yellow color mottling. You can see different colors like this. This is called nothing but jarosite. So if you found this type of condition in any profile, definitely you should give J. If you give double J, students, what is the meaning of that? It is a cryoturbation, mixing. Cryoturbation using of because of it is a mostly you can see in B and C horizon, students. Churning you can see some churning materials you can see because of freezing and thawing. Due to the freezing and thawing conditions, we can see this. You should give this type of notation JJ. If you give JJ notation, means that is called cryoturbation. If you say you use one single J, it is called accumulation of jarosite. So be careful, students, and remember this. So K means accumulation of secondary carbonates. If you more BK, especially whoever student you're following the Chagall textbook, you can see BK. BK means nothing but it's the accumulation of secondary carbonates. Mostly you can see B and C origins. You can see an accumulation of pedogenic carbonates. Usually calcium carbonate, students. If I mention BK means it's accumulation of calcium carbonate. So remember this, students. If I give any K means that's called calcium carbonate. Coming to the next. If I give double K means it is nothing but efflungament of secondary carbonates. So remember, efflungament is impedant. Here in previous, don't confuse, students. It is a accumulation. It is something different. Sorry. Next. It is nothing but just efflungament means it will just depositing, not accumulation. So it's somewhat different. Of horizon of secondary clement, mostly you can see B horizon with the fabric is plugged with a pedogenic calcium carbonate. 50%, there will be more 50% with double K means there will be more calcium compared to previous one. So coming to M means cementation or induration. So M means nothing but cementation or induration. So mostly use this is also mostly present in B and C, students. Most 90% of horizons complete cemented, root penetration only to the cracks. So mostly there will be cementing material will be very high. Roots will be enter only through the cracks if there is only cracks will be there. So most of the students that cement based on the cementing material which is present in that particular layer or in that particular horizon, you can see different notations. So if I give double KM or KM, it is a cemented by the carbonate. If I give QM means it's cemented by the silica. If SM means it is nothing but iron. If YYM means it is cemented by the gypsum. If KQM means it is a both carbonate. Silica means ZM means salt more soluble than gypsum. So this is a reading. So more soluble gypsum. So these are the different types of notations or subordinate notation, subordinate endurations which we usually give this for the particular profile. This is regarding M. Coming to the next, students, marl. So marl means indicates as limnatic material of marl used only for MM is nothing but limnatic materials. MA. So if you have a marl, there is another material called marl means it is used only for the L horizons. And coming to the N, student, it is nothing but N means accumulation of exchangeable sodium. If you found any much more amount of sodium condition in that particular layer, means definitely you should give a name called N. N, that is that notation, not name. Notation means N. So it is called dominated by the sodium. O means small O, students, not big O, small O. Small O means mostly used for the B horizon, students, having some inductive residues as SQ oxides. Mostly you can see gypsite, geotite, and hematite. You can see mostly resulting accumulation of SQ oxides. So small O means it is a accumulation of SQ oxide. Small n means exchangeable sodium. M means marl. Marl means one type of material present in the L horizon. We will give notations for that. So coming to the next, students, P. P is nothing but is formed by this particular or layer is formed or horizon is formed by tillage or other cultivated disturbance, mostly by the ploughing or other tillage activity. Mostly this P symbol is used with the O mostly because usually there is organic matter and that organic matter was continuously ploughing with some top layer. Generally we will give notation OP. If you OP means that is called organic soil material having some A properties. Also generally this type of cultivation practice, this P is completely mixed. Sometimes we will give combination with EP, BC, or C horizons also we can give that. So there is a P. P means nothing but, in short, you should remember tillage. It is formed by tillage or other cultivation disturbance. Due to this particular tillage cultivation disturbance, this particular P was formed. So plow layer generally will say, no, that is called a P. This is regarding this P horizon. So Q means accumulation of silica, students. Q, if you give small q means is accumulation of silica. So this symbol is used with B and C, students. So generally, more accumulation where will happen? Generally, it will happen in B and it will happen in C only. So whenever there is a silica accumulation is there, we can see it is a Q. So R means it is nothing but weather or soft bedrock. If you give any matter, mostly you can see in C layer, you can see this. So moderately cemented, weakly cemented conditions you can see. So mostly what kind of materials we can see in this type of R? We can see sparolite and partially consolidated sedimentary rocks. And it is that rock that is hard enough that roots only penetrate the cracks, but soft enough that it can be dug with a spade shovel. So what is the condition of this R, students? It is very hard that roots cannot be can be go only through along the cracks, but it can easily remove by the shovel. Shovel means that implement tool which we spade or shovel. You know what is the meaning of shovel and spade. So based on that, with the help of spade or shovel, we can remove this material. So that material is called as R. This is regarding with R, students. Coming to the next, alluvial accumulation of silica oxides. Alluvial accumulation of silica oxide, students. S means alluvial, it's completely silica oxide. The symbol is only used for the B horizon, students. Because accumulation, whenever you heard accumulation, definitely will happen only in B. That's why you can see BS, BK, BT, all this type of notations will be see only in S. So this accumulation will be amorphous material with the dispersed complex of sesquio oxides. So all these materials will be comes in, and also the color value of chroma in moist condition it will be more than 4. The color conditions will be more than 4. It is used in conjunction with the H. So we generally what will give? It is sometimes it will be some conjunction means it will be combined with sometimes H also. H, so that's why we will give notations called BHS. If the color value is chroma is much less than 3. If it is more than 4, it will be only BS. If it is less than 3, it comes in as BHS. So like these students, we will continue. So so coming to the SS, if you give double S means nothing. Silkiness. Silkiness are found by shearing failure. Shear failure, students. Shear failure means that that holding capacity. What shearness, shear failure, all this comes under consistency property, which we have explained in the previous lecture. So this comes under that particular. So if there is any failure in shear failure of clay material swelling upon wetting, upon in swell upon wetting. So whenever we give any wetting condition for any particular clay material, what will happen? It will be swell. So there will be some failure in shear means that holding thing will be destroyed. It will be disturbed. So it will be slides. The silkiness will be slides indicated the vertic characteristic. So that is called the S, student, double S. So T means, if you give any T notation means, that is nothing but called silicate layer. The accumulation of silicate layer generally, that is called the T, student. So when if so for example, if the particular B horizon was accumulated with silica means, so generally we will note it as BT. So we will suppose just for example there is a B horizon, master horizon. So that particular master horizon was accumulated with silica. How should we give notation in the particular records? We should give BT. Then generally we can see it's called the BT. BT means accumulation of silica. So there is a master horizon B. In that master horizon B, there is accumulation of silica. So remember this, students, in exam they may ask like this, B, by showing some confusion. So be careful about these notations. So indicate accumulation of clay either formed with, sometimes we can either, sometimes this type of accumulation either from within the horizon or subsequently move to the other. Sometimes it may move to the sea also. So this evidence of clay elevation or migration indicates the clay coating on the pet pores. So what will happen? Sometimes, student, this accumulation of silica, maybe it will be surround, it will be move in and around between this in the horizon only. Sometimes it will move to or subsequently migrated to other horizons also. What will happen during this movement? You can see some coating. You can see the clay particles. You can see some coating. The silica coating will be there. That is called the mottles. No, that is called the mottle. Brain it will form the bridge between all the pores and all this. So you can see mottle layers. So generally, although usually it present B horizon, it may be generally most of the silica will be this type of T type of characteristics will be present in B horizon. But sometimes it may go to the C also, C and R or R layers also will be moved based on the climatic conditions. Coming to the next students, U, human manufactured material, mostly artifacts. If you see any bricks, wooden products, or glass, or any other plastic, etc., especially this is very famous nowadays. If you found all those nonsense, means definitely that is comes under you. That is was produced by our the great human manufactured materials. And coming to the V students, you can found some plenity. No, pronunciation is somewhat for me. It is difficult. Plenty material will be there. What is the indication? That is nothing but indicate the presence of iron rich humus poor reddish material. So V means it is iron rich humus poor reddish material that is firm of or very firm. It will be firm or very firm when moist. So when you give some moist, it will be very firm and moist, and it's less strongly than cement. Though it will give some strong firmness, but it will be less stronger than cemented. When compared to cemented conditions, it is somewhat less stronger. So mostly you can say mottled pattern will be there because of this iron rich condition. You can say red, yellow color, gray colors, that mottling color, that coating, and that coating on the particular layers is called the mottles. So generally because of iron condition is there. That's why we can say some mottles of red, yellow color and gray color. Upon exposure, general students, if you whenever you have a chance upon road cuts, especially in while you're traveling on road cuts, this material you can see, but it will be completely altered. Altered. What will happen? The color may be changes. The material may be somewhere. The material may be disturbed. What will happen? The symbols may be used for mostly B and C. Mostly we use these symbols for mostly B and C only. Coming to the next students, W, small W student, not big W. The symbol used for development of color students, development of color and structure. Development of color usually redder than A and C. Generally based on the color, especially this is also used for only B. What will happen usually for redder than A and C material? So soil structure, but not applied for alluvial accumulation generally. But remember students, this color may be come from where, except alluvial accumulation, the color may have formed in B horizon, means generally you should give it as a W notation. X means fragipan characteristics. What is the fragipan? There is one of the epipedon or endopedon. Anybody can give answer? What is the fragipan? Epipedon or endopedon? Can anyone say? Can anyone say what is the meaning of fragipan? Okay, Vedavyas, fragipan is epipedon or endopedon?
Man-made.
Man-made, okay. అంటే అది ఎపిపీడన్ or endopedon? I'm sorry, I think you are not, you're not practicing after the class. Okay, anyhow, I hope after end of the class, someone will answer for this. So the mostly the symbol is used for axis. This is small subordinate class. So with this, mostly we can see this used for only B and C, and design genetically developed firmness or brittleness of higher bulk density and adjacent layers, but not cemented. Here also it's not cemented. Mostly used for B and C. Some parts of layers are root restrictive. In this, if you this fragipan conditions also, you can see some root restrictive conditions. So Y, this Y means BY. Y mostly you can say accumulation. This is also accumulation, but this accumulation is gypsum accumulation. Don't forget, if it's gypsum application, that you can see Y. If it was a double Y, means gypsum accumulation was too much. It was very high. That is called the dominance of origin by gypsum. It is accumulation, it is dominance. See the difference. Y, one Y and double Y. Mostly you can see B and B, you can see B and C both, you can see indicate the pedogenic gypsum accumulation. But here you can see more than 50% is almost. If you see any particular layer, that particular if is dominated by the horizon, means you can see 50% is dominated by the Y. So Y you can see this. Coming to the next, Z. Z is nothing but accumulation of some accumulation of salts more soluble than gypsum. So with the gypsum, there will be some soluble salts also will be mixed, especially so that type of notation we will use one notation called Z. So the symbol is B and C. Identify accumulation of salts are more stable than gypsum. Example called halite and toner. So like this we can send also student the subordinate designation or subordinated these small letters are used as subordinate designation. Sometimes they may use as one suffix to other because to the characteristics, especially example for BHS. So B is a master origin, H is one character, B is this smallest is one character. except CRT site it won't give any notation. So like this, by using these different types of notations today, notations are sometimes our designations, mostly designations. So master horizon. So after master horizons, we can see some this subordinate or the small horizons also we can see. Transition layers, we can say transition layers means combination layers. So we will give different names based on the accumulation, based on the material of accumulation. If silica means it has different accumulation, gypsum has means which is different accumulation. So like this, we will give different accumulations, etc. Based on that, we will decide all these things. This is for today's class, and tomorrow we will discuss about this one, diagnostic soil material. But we have completed this, students. Horizons means that endopedons, epipedons were completed, but diagnostic material we will discuss tomorrow. What are the different diagnostic materials are there? What is the difference? So it is very somewhat not today's like this.